Okay, now let's solve the following problem. Given the following function, f of x is defined by this integral. Let's say we can define from 0 to x 1 square root of 1 plus t cubed dt. Okay, so the value that we want to find here is the value of the derivative of the inverse function at x equals 0. So one of the keys here is that to be able to compute the f inverse at 0, we have to find f inverse. But it's not that easy to find it. So we have to integrate this one and try to find the inverse derivative of a cubed root. But there is a shorter way of doing this problem. So if we can graph this one, the minus 1 is 0, 1t is 0, something like this. Okay, so approximatively, so it's going to be increasing 1 plus t cubed. So this is minus 1 and it's going this way. So we see that this one can be injective, and when it can be injective, we can find only one. It doesn't prove that f is surjective or that f is bijective, but injectivity let us find one value for this 0. So that's the key here. So we're gonna prove that we prove that f is injective. How to do that? We assume that f of x is equal to some f of x prime. Okay, this x and x prime, and we want to show that x is equal to x prime. Okay, that means it can't have two different values. So it's this one and this one. So it has a value that it's one value. It's not like the cosine. Okay, so the cosine here at 0 is 1, but at 2 pi it's gonna be 1 too. Okay, so it's not 1 to 1, but here we can prove it. How can we do that? So to arrive at this result here, we can, if we implement this condition here first. So what's f of x equal f of x prime? So this one means that the integral between 0 and x of 1 plus t cubed dt is equal to 0x prime 1 plus t cubed dt. And from here, how can we get this result? Okay, it's not obvious, but if we can differentiate both sides, so taking the derivative of this one and this one, we get, using the fundamental theorem of calculus, 1 plus x cubed is equal to, we're gonna get the 0 part is gonna go. So we have 1 plus x prime cubed. So we get only the value of x, and the 0 is gonna go. It's 1 here. 1 it's gonna go. It's gonna cancel in the derivative. So from here, so since these two quantities are defined we have no problem with this because the function is defined on -1 infinity. Okay, so we can take the square root. Once we do that, we get 1 plus x cubed equal to 1 plus x cubed here, and this one gives us x cubed is equal to x prime cubed. But from here, we're going to use this fact that x cubed minus x prime cubed is equal to x minus x prime times x squared plus x times x prime plus x prime squared. This is an equality and a remarkable identity. But if we set this one equal to 0, gives us x minus x prime equal to 0, or x squared plus x prime plus x prime squared equals 0. This one is never 0. Therefore, we have x minus x prime equal to 0, and this gives us x is equal to x prime. So this proves that f is injective. So what can we deduce from here? So if f is injective, we are looking for the derivative of 0, the inverse function at 0. Okay, so which value would give us 0? Okay, so this is the question that we have to see. Okay, so if x is 0, so we're gonna have f of 0 is 0. Okay, and this is the only one, because we proved that f is injective. Okay, and therefore we can find that f inverse of 0 is 0, because f is injective. There is no other value that would take this value for 0. Okay, so once we have that, we can say that f inverse derivative of 0 is 1 over f prime f inverse of 0, which is 0, which gives us 1 over f prime of 0. But what's the derivative of f prime? According to the fundamental theorem of calculus, it's f prime of x is 1 plus x cubed, the square root of 1 plus x cubed. And once we plug 0, we get 1. That means the derivative is equal to 1. This proves that f minus 1 prime at 0 is 1. That means the derivative of the inverse function at 0 is equal to 1. And that's the value that we needed to get. Okay? Thank you.